Our next speaker is Ty Martin, who will be speaking on computational investigations of the intersections between bioactive compounds and biological assemblies. Ty.
So today I'll be talking to you about Alzheimer's disease and the critical need to develop sensors for early diagnosis. So Alzheimer's actually is the 6th leading cause of death in the US currently, and it affects about 6 million people right now. But what if I told you that number is going to reach 14 million by 2050? So right now there's really no way to diagnose Alzheimer's in an early state. In fact, the only way to really do so is after death, when you actually observe the brain and see the problems that arise. And so Alzheimer's has 2 specific features that you see in the brain. They are called amyloid plaques and neurofibrillary tangles. And these are basically large lesions that sort of disrupt the communication of your brain. So if you imagine the brain being something like a power station with the lines reaching the rest of the body, well, these plaques sort of disrupt that communication, and so your brain no longer functions properly. And the plaques specifically are made of these proteins. And these proteins are actually naturally in the brain, and they have a function. But in Alzheimer's, they misfold and clump together or aggregate to form these plaques. And so this brings me to the critical research that I'm involved with, which is to develop a way to diagnose this early on so we can begin treatment sooner. And currently there are a class of specialized, unique small molecules that are developed by the Witten group here at UNM, and I'm actually involved with that group as well. And so my research specifically is using computer simulations to understand how these special molecules can be used as a sensor. And what happens is these molecules, we call them OPEs, they're a little bit like a light bulb. So they bind to these protein aggregates and give off a measurable signal. So it's like the light bulb turning on. And the reason that we think this happens based on my simulations and our experimental results is that the OPEs bind to specific places on these aggregates. And when this happens, there are something called intermolecular forces going on. So if you imagine magnets sticking together, it's something similar to that. And so what we hope is that we can engineer and further refine these OPEs to be able to be used for other types of neurodegenerative disease, like maybe Parkinson's in the future. And so we hope that eventually our research will lead to early detection and hopefully a treatment and cure for this disease that affects so many. Thank you.
So Ty, when you talk about the future, how far into the future are we talking about before some of this has some application?
Right, so right now we're actually testing the OPEs on mouse and rat models that have Alzheimer's. And so we hope that, I'm thinking maybe in the next 10 years we could try some clinical trials. So
I think I'll probably need one, so I'm ready. Where are you from, Ty?
I'm from here, from the Moriarty and East Mountain area.
Okay, great.
Yeah.
And what made you pursue this line of research?
Right, so I actually have a muscular dystrophy which has proteins that misbehave. And so that sort of piqued my interest, finding ways to sort of help treat these diseases that are serious. So
great.
yeah.
Thank you so much, Ty.
Thank you.